Okay, this is section 2.2, graphs. So now we're looking at the graphical representation of functions. Graphing with a calculator. In order to graph with a calculator, we must enter the function in the y equals menu. Our calculators can only graph something that looks like y equals something or f of x equals something. Remember, functions are always that way. You sometimes need to remember, though, that we will use other letters as the independent variable besides x. X is the most common one, but occasionally we use t for time. So the independent variable is what's in the formula, and the name of the function, which is usually going to be y in the calculator, because we're, after all, pressing the y equals menu. So we've already entered functions through the calculator in order to make a table of values. So instead of doing the table, you just hit the graph key itself, which is the far right-hand key below the screen on the calculator. And that will draw the graph for you. So as an illustration, let's graph y equals negative 2x squared plus 4x plus 3 on the calculator. Notice it does say y equal. So our solution. Okay, we're going to enter y equals negative 2x squared plus 4x plus 3 into the calculator. Okay, I put it into y1. Let's go ahead and play along with the home game here. So let me get out my calculator. Press y equals negative 2x. Okay, there's my squared. Plus 4x plus 3. Okay, now you can either quit the screen and then do graph, or if you want to, you can just go ahead and press graph. And there it draws it for you. Okay, it's coming up there. Now, those of you that have been through high school algebra, you know that this thing is called a parabola. It's actually a parabola upside down. So anytime you've got an x squared, that's what it's going to look like, either this or the parabola upside down. This looks like a U turned upside down. So to graph the equation, again, you're going to either quit that screen and press graph, or simply press graph itself. Sometimes it's kind of a weird thing with the TI calculators, is that sometimes you have to quit the screen before you try to do something else. So if you're in the habit of always quitting the screen, it's actually a good habit. So anyway, there's our graph, which we've already seen on our calculator. So again, this shape is called a parabola. Okay, if you look at our viewing window here, notice it's not really square. It's longer in the horizontal direction than it is in the vertical direction. That means each of the tick marks on the x-axis, on the horizontal axis, are slightly further apart than on the y-axis, even though they both go from the same values left and right as they are from bottom to top. The viewing window. Okay, the graph below, which is again y equals negative 2x squared plus 4x plus 3, this is called the viewing window. Ideally, we would like the viewing window to show enough of the graph so that we can see any relative maxima, relative minima, any inflection points, and limiting values, and so on. A lot of people, they like to see where it crosses the x-axis, which those are the x-intercepts, and of course I can see them here. A lot of people like to see where it crosses the y-axis, which is the y-intercept. So notice, this is a good viewing window for this particular graph. I can see intercepts, I can see a max, and there aren't any limiting values, and there is no minimum value, so this really is a good viewing window. This was the default viewing window on the calculator. Settings for the viewing window. Okay, to see the settings for the viewing window, you press the window button. Okay, the window button is the second button from the left below the screen. If you press the window button, you get this screen. Okay, now on the 83s, these last two entries aren't there, and that's actually a good thing, because these last two entries really are just borderline meaningless. They really shouldn't be there at all. They aren't necessarily what you think they are. They're somewhat misleading, and I don't know why TI did what they did with them. It's really, and you don't even need this that says XRES. You don't even need that. It's these right here that you really need. The X-min, X-max, X-scale, Y-min, Y-max, Y-scale. Those are the ones that we really need. These others, there's really no need for you to ever mess with them. Now, the meaning for each of the settings is as follows. So we're going to run through what each of these mean. And again, really, these bottom three should never be messed with. So again, there's our window settings. Okay, X-min equaling negative 10. Okay, that's what it is in this situation. It's negative 10. This gives the smallest x value on the horizontal or x-axis. Remember, the x values are the independent variable, so by default it's always negative 10. Now in certain situations, like physical situations where the independent variable cannot be negative, you might want to set x-min to be 0. That way you're not seeing stuff that doesn't matter. Okay, x max equaling 10. Okay, This gives the largest x value on the graph. Now remember, the x values are on the horizontal x-axis. Now sometimes you might have to make this bigger because you may not see anything until x becomes incredibly huge. Okay, we had that situation with some limiting values. And then we have the corresponding idea for the y's as well. Now there's one more x setting, x scale. That's what the SCL stands for. Okay, x scale in this case equals 1. This gives how we count the tick marks on the x-axis. That means each individual tick mark would be 1. If you change it to 2, then each tick mark would be 2. So if you had a huge gap between your x-min and your x-max, you might want to set the scale to be 50 or 25 or 100. So by default, the x scale is 1. Now we have those exact same entries for the y. So the y-min being -10. That's the smallest y value on the y-axis. Remember, the y-axis is the vertical one. Again, sometimes we don't like to see negative functional values, so you might set that equal to 0. Okay, the y-max, that gives the largest y value on the y-axis. Remember, the y-axis is the vertical axis. Now again, sometimes like if you're doing money and it's into the thousands of dollars, you might want to change your y-max to be something rather large. And then the y scale is again what each one of the tick marks on the y-axis mean. If you have a huge gap between your y-min and your y-max, you might want to set the scales to not just be 1. You might want them to be 10, 50, 100, something like that. Now again, by default, it's 1. So those are the ones that you should really mess with: x-min, x-max, x-scale, and then their corresponding y's: y-min, y-max, y-scale. These others, you really should just leave them alone. In fact, it turns out you really can't control delta x and the trace step. You really can't control them. It seems like you could, but you can't. The XRES, okay, the res stands for resolution. This gives the pixel resolution on the screen. It should always be left at 1. There really is no reason to change it. A pixel resolution of 1 means that the function is evaluated at each pixel on the screen. If you change it to 2, for instance, that means that the function is evaluated at every second pixel on the screen. So that means it might start to look fuzzy. So again, don't ever set it to anything bigger than 1. In case you're wondering, well, why would you want to? Why would you want your graph to look fuzzy? It's to make it draw the graph faster. Because you may have noticed it took a few seconds before it actually drew our parabola for us. The TI-84 does have more pixels on its viewing screen than the TI-84. So sometimes the the 83, excuse me. So sometimes the TI-83 is much faster at graphing because it doesn't have to make as many calculations. Because the calculator actually is making a table of values. It's just that it's doing in the pixel step. Now the delta x, it's half the step size of the x values. Now I have no idea why TI made it half the step. It seems more reasonable that it should be the full step, but for some reason they just didn't do it. Okay, in the trace step, that gives the amount that is added to or subtracted from the x values as we move along the graph using the trace feature. Okay, if you actually look at those two, you may have to take out your calculator itself to verify this. This value is half of that value. Or I guess, or another way of looking at it, multiply that value by 2 and you get the trace step. But again, these 3 settings should be left alone. So note, not all the calculators will have all of the above settings. The first 5 are the ones that we really, truly need to play with. The others we don't. So remember, it's the max, the min, and the scales for each of x and y. Now, when giving the settings for the viewing window, it looks something like this. -10, 10, 1 by -10, 10, 1. These are the x settings. These are the y settings. So the first set of 3 numbers are the minimum, maximum, and scale for the x-axis, and this set of numbers is the minimum, maximum, and scale for the y-axis. So it's always x, then y. So minimum, maximum, scale. And it's always enclosed in brackets, not parentheses. Okay, the standard viewing window is the -10, 10, 1 by -10, 10, 1. That is the standard viewing window. It's the default viewing window when it comes out of the factory. So if you start to change it, those values will change and they'll stay changed. Okay, they'll actually stay changed unless you go back and set the window back to being standard. Tracing the graph. Okay, this is sometimes done in order to read off some values. So once we have a graph in the calculator, we can move the cursor along the graph. This is called tracing the graph. We use the trace feature of the calculator to do this. The trace key is the fourth key from the right below the calculator screen. So remember, we've already done y equals negative 2x squared plus 4x plus 3 in the calculator. If we press trace, this is what appears. Now you can't tell in this, but that's flashing. And notice the name of the function that we're tracing is given up there. And this also gives me the location of where the cursor is. Is that x equals 0 and y equals 3, which I guess you can tell. If I do it on the calculator here, oops, I guess I got to turn it back on. If I do trace, okay, notice it's at 0, 3. To move along the calculator in the right direction, just press the right navigation arrow. And notice it tells you where you are. These aren't great values, but it does tell you where you are. If you want to go in the left direction, press the left arrow key. In case you're wondering, what do the up and down do? Nothing. Okay, because remember, the graph does not allow me to jump off of it. That's what these would do. The trace keeps me on the graph, and you want to just move left and right in terms of the x-axis. So notice you really can't move up and down in terms of the y-axis. Only left and right. So you can play around with tracing. And this gives you an explanation of what would the up and down navigation keys do. They jump you to another graph. Okay, I only have one graph in here, so that's why it doesn't jump around. I guess just for fun, let me go ahead and put in another graph. Okay, so quit this, go to y equal, and let's go to something simple. Let's graph 2x minus 5. Okay, let's just say graph. Okay, now if I press trace, notice it's still on y1. If I go down, notice it jumps to the line. If I press down again, it jumps back up to y1. If there had been a y3, it'd go to y3 and so on like that. But if I jump back down to the line, again I can move left and right along the line. So that's what the up and down will do. They jump you to different y's that you have put into your calculator. So now if you wanted to enter a specific value for x, you just simply key that in. Okay, now I did 5. Okay, so if I pressed x equal 5, there. Okay. And I press enter, and it tells me the point that's on the graph is 5, negative 27. Notice that's way, way, way down here. So even though it can't show it to you on the graph, it does in fact at least give you the y value. And again, you should verify that if you let x be 5 into the formula for y1, you do in fact get negative 27. If I do it on the calculator here, since I've got two different graphs going, notice it's on the red one. So if I pressed in 6, let's say, notice by default it's x, and then press enter, it tells me the y value is up here at 7. Notice I do happen to see that. And here is, remember, this is the formula for y2. So 2 times 6 is 12, 12 minus 5 is 7. If I jump to the blue one, and I give a specific value for x, let's say 2, and press enter, the point 3 is for the y value. So 3 is the y value. So my point is 2, 3. Okay? So just when you give it an x value, be sure, and if you have more than one function given in your y equal menu, be sure you're on the right graph. So again, you can jump directly to a particular x value. You can't really give it a y value. It's only an x value. And you just key it in from the keypad and press enter. And it gives you the corresponding y value. And if it can, it'll show you the point on the graph. So again, the value of y being negative 27, it's way off the graph. It gives me the value, but it cannot put the cursor there. So now again, please note that depending on your particular model of calculator, you may not have all of these features. Okay, you can also find x values and the corresponding y values by using the table. So let me show you with this calculator that has two functions given. So let me quit this menu or this screen. If I do table, notice I've got my x's values for y1, values for y2, and so on. If you put in more functions into your y equals, you would just fill up these other columns. And again, it always tells you which one it is, y1, y2, and so on. Now again, you cannot enter y values, only x values, only the values of the independent variable. Because remember, you pick the independent variable. The dependent variable depends upon what you give for x. Choosing a viewing window. Kind of like when the standard window doesn't work, what do? Consider the following function. F of x equals x cubed plus 5x squared plus 2x minus 1. Okay, I've entered it into the y1 into the calculator, and it looks like this. Hopefully by now you've kind of noticed that y1 is always the graph in blue. Okay, if you look at this, where I would have a maximum, a relative maximum, appears to be chopped off. So this is not a good viewing window. So because we might want to play with it, let me go ahead and put this into the calculator as well. So let me bring this up, quit that, go to my y equal, get rid of that guy, and I don't need y2 anymore, cluttering things up. So let's see, I've got, once again, I've got x cubed, okay, get out of the exponent, plus 5x squared plus 2x minus 1, and we graph it. So again, this is the standard viewing window, and my relative maximum, I know there's got to be one there because it's going up and then coming back down. I don't see what it is though. I can kind of read off the relative min. So again, our graph is chopped off. So the standard viewing window is just not good enough. Because remember, we would like to see those hills and valleys. So this would not be an appropriate viewing window. Now, there is no such thing as the appropriate viewing window, so it's kind of we're choosing a viewing window. So in order to find these values, we're going to use the trace feature to look at the table of values, or excuse me, we can use the trace feature or look at the table of values to figure out a max and a min. So it appears that the maximum value occurs somewhere between -4 and -2. So if I look at the table of values between x equal -4 and x equal -2, okay, I mean, there it is. Okay, there's -4, there's -2. Notice I've got really way down there, it's coming up, 7, 11, and it drops back down to 7. So it looks like I should at least include x being -3, and for my y max, I should probably have something bigger than 11. Notice this just keeps getting bigger and bigger and bigger, because we could see that from the graph, that as I move away from the origin, I get bigger and bigger values. So perhaps maybe, just in case the maximum did not really occur exactly at -3, I want to get my y max something bigger than 11. I don't see any need to change the x min and the x max. I'm going to keep them at -10 and 10. But I do have to change my y max. It should be, again, be something bigger than 11. I don't know if you're thinking 15. 15 does sound good. If you're thinking 20, that's fine too. So something bigger than 11. So these are what I'm using. The x min, x max, and the x scale, no change. My y min, I'm making stay at -10. It's my y max, it's going to 15. So with those settings, that's what my graph looks like. I can now see the relative max. So let me do it on this other calculator in case I want to play with it some. So let's see, all I did was what? Change the y max. Changed it to 15. And then I graph away. Now, as you look at this viewing window, again, it's not unique. You're just saying, I would rather use 20. That's fine. If you say, what about 12? Since we can experiment, I wonder if I'd used 12, would that have chopped off? Would I still not be able to see it? So let me go to Window, and let me try 12 for the max. Sometimes I like to keep those to be multiples of 5 or something like that. We can still see it, right? We can still see the relative max, relative min. But this graph illustrates something that I want to point out to you. the origin is no longer in the center of the screen. Okay? If you do change something like that, the origin can sometimes move around. Now you're probably saying, how can I put the origin back in the middle? Well, since I'm playing with this one, if I made my y max 12 to keep my origin in the middle, I should make my y min negative 12. It's kind of like the y max and min are opposites of each other. Same thing with the x max and min. If they're opposites of each other, you can keep the origin centered in the viewing screen, which is kind of nice. Hopefully you can now tell, yeah, the origin is now back in the middle. Okay? And whether or not that's more pleasing to the eye, I don't know. Now, sometimes when you're doing the graphs in WebAssign, he will actually tell you the settings that he used for the viewing window. If he does that, go ahead and do those settings on your calculator, and so that way you can compare graphs, especially if he's asking you to give an answer and it's multiple choice. So again, if you want to keep the origin in the middle, the x max and min should be opposite of each other, and the y max and min should be opposites of each other. So again, the coordinate axes are no longer centered. The origin is no longer in the middle. Okay, now again, personally, I don't really like it, but there's nothing wrong with it. Now again, the way around that is make the x max and min opposites of each other. You know, one plus something and the other minus the same thing. And same thing with the y max and min. They should be opposites of each other. You know, plus or minus 12, plus or minus 15, something like that. Now the settings to get a better view of a graph, they're not unique. So remember, you want to be able to see all relative extrema, and ideally also x and y intercepts. And if there is a limiting value, which there isn't in this one, you'd like to be able to see limiting values. Now again, if you want to get back to the standard viewing window, you know, to stop all the stuff you played with, you're going to press zoom, and choice 6 is the standard. So if I go back to this, so zoom and choice 6. I really have no idea why TI put all these Z's in front of everything. Those are the only two that make sense, zoom in, zoom out. But these others, I don't know why he did it. So just press 6, and you'll go back to the very first graph that we looked at with this function with the relative max chopped off. Some examples. Let's find a suitable viewing window for each of the following, and then graph the function using that suitable viewing window. Again, remember, what I find may not be the exact same thing that you find, but we should be able to see the same features on the graph. So here's the first one. The population of fish in a lake is a function of the initial population P sub 0 of fish in the lake, the growth rate R of the fish, the carrying capacity L of the lake, and the number of months T since the initial population was observed. We can express this function as P of P sub 0 RLT is equal to L times P sub 0 e to the RT all over L plus P sub 0 times e to the RT minus 1. Probably saying, well, that's way too many letters. Now it says, suppose that a particular lake is initially stocked with 400 fish. Suppose that the lake has a carrying capacity of 2,500. If the growth rate of the fish is 32% per year, answer the following. In part A, express the population of fish in the lake as a function of T, which is equal to months since it was stocked. Question B, find the population of fish in the lake 5 months and 10 months after it was stocked. Round your final answer to the nearest whole number, because after all, these are living animals. Question C, find an appropriate viewing window for the graph and display the graph in the appropriate viewing window that you found. Question A is really making you reduce this function of 4 variables down to a function of just one, namely T. Remember, our graphing calculators can only graph functions of one variable. They cannot graph functions of several variables. Okay, our solutions. Okay, again, the setup is there. In part A, this is what we're given. Okay, we were told that you were initially stocked with 400. So P sub 0 is 400. Okay, remember the carrying capacity was given as 2,500, right? Carrying capacity, 2,500. Well, and there's our growth rate, 32%, which is a decimal 0.32. So our growth rate is 0.32. T remains the only variable. So I plug these numbers into this function right here, and I leave T as the only variable. So I have P of these four variables just becomes P of T, and it's 2500 times 400 e to the 32t over 2500 plus 400 times e to the 0.32t minus 1. I'm only to do 2500 times 400. So what is that? 1 million e to the 0.32t all over 2500 plus 400 times e to the 0.32t minus 1. There's the answer to part A. Notice we've got huge numbers. Okay, question B wants us to find the population at 5 months and 10 months. So for question B, that means we need to find P of 5 and P of 10. Now, since we're going to have to graph the function, I'm going to go ahead and enter this into the calculator and then use the table with step size of 5 starting at x equals 0. Because remember, I want P of 5 and P of 10. So let's go ahead and enter this into the calculator. So clear that out. Our y equals, clear that out. So I've got, open my parenthesis. Okay, that's 1 followed by, what is that, 6 zeros? Yeah. 1 followed by 1, 2, 3, 4, 5, 6, and then do second ln my exponent 0.32t, 0.32t. Again, notice the calculator is calling it x. Get out of the exponent. Come on, get out of the exponent. Close the numerator. Divided by, open denominator, 2500 plus 400, open parenthesis, second ln 0.32t, get out of exponent, minus 1. Close the parentheses after the minus 1, so I'm closing that one right there, and then close the parenthesis for the denominator. Okay, and we quit that. Now, I said I was going to do my table. If you wanted to do your vars, y vars, and do P of 5, P of 10, that's fine. Notice, since it's in the calculator, it would be like y1 of 5, y1 of 10. But if I do my table set, second table set, start at 0 and have delta table be 5. Okay, and then just go to the table. Okay, so P of 5 to the nearest whole number is 1,214. And P of 10 to the nearest whole number is 2,059. So there's the result of everything I did. So again, P of 5 to the nearest whole number is 1,214, and P of 10 to the nearest whole number is 2,059. So there's the answer to part B. Okay, now we're now supposed to graph it. Okay, so we got to get a nice viewing window. Remember, we had some huge values. Okay, just looking at this, our y max probably needs to be rather large. Also, notice after a certain stage, it stays at 2,500. Because remember, that was the carrying capacity of the lake. It was never going to exceed 2,500. Did the fish start to die off for whatever reason? So, for an appropriate viewing window, we make some observations. Okay, time cannot be negative. So x-min will be 0. Okay, you can't have negative time. Okay, now looking at the table above, again, I got to the carrying capacity of x was greater than or equal to 40. So I'm going to set my x max to be 50. You know, something slightly bigger. If you wanted to do 45, that's fine. But you know, I'm doing 50. So if I'm going to go from 0 to 50, my x scale, I'm going to use 5. That way there will be 10 tick marks. Now the number of fish can't be negative, so y-min should be 0. And again, looking at the carrying capacity, I can get up to 2,500. So if you want to use 2,500, that's fine, but I'm going to go just a tad bit bigger. I'm using 3,000. Now notice I'm going from 0 to 3,000. So my y scale, I'm going to let it go up in increments of 100. So notice even then I'm going to need 30 tick marks, right? So let me go ahead and put those settings into our calculator. So calculator, get rid of that. Window, minimum of 0 for x min. I chose 50 for x max. I said I would go up in increments of 5. Y min I chose to be 0. Y max I chose 3,000. My y scale I chose to be 100. And let's graph it. Now notice by having x min and y min both be 0, it puts the origin down here. Okay, and now it looks like I'm getting close to the carrying capacity. Okay, sometimes if you're saying, I would like to be able to read off some sort of a grid, do second format. And right here it's like you can turn the grid off or on. You can make it dots or lines. I'm going to make lines. So enter that. And graph it again. Oops, I guess I got to quit this screen, huh? Have I locked up this calculator now? Looks like I've locked it up. Locked up the computer as well. Okay. Let's see if I can get out of this. I'm pressing Control-Alt-Delete to bring up something that'll let me turn these things off. Hopefully I won't accidentally shut off the computer. Okay, I wanted the task manager. Okay. It's telling me that it stopped and recovered. Okay, so I don't need that anymore. Okay. Let's quit this screen. Quit the screen, graph it now, and see there are the grids. Okay, I don't know if that helps or not. Some people like it, some people don't. Doesn't hurt. Remember, if you don't like it, just do second format and turn it off. Oops. So again, there's my graph. Okay, I kept the grid here. So I graphed it with the grid lines turned on. And again, notice I've reached my carrying capacity. What would be kind of nice, and this is something for TI to do, is if they would actually put numerical values for the scale, for the tick marks. Okay, at least every once in a while. And I guess that's when you got to go back and remember what your settings were. On the X scale, each one of these was 5. You have 5, 10, 15, 20, and so on. On the Y scale, it was 100. So, 100, 200, 300, and so on. Hey, remember, it crosses the Y-axis. Remember, we initially stocked it with 400, so it should be at the 4th tick mark. Does it look like it is? Okay. So again, it's not a unique setting, but it's a pretty good viewing window. Number 2, let's find an appropriate viewing window for this function. F of x equals x cubed minus 9x squared plus 2x plus 17, and display the graph on the calculator. Now you should always start off with the standard viewing window, because maybe it is a good viewing window. So let's get out of this. Let's go to our calculator. Let me quit that screen. Okay, let me clear out my y equals. Goodbye. Let me set my standard window. So I did zoom, choice 6. Okay, I think I'm going to keep the grid on. Okay, it doesn't look bad. So quit that. Y equals, okay, x cubed, get out of the exponent, minus 9x squared plus 2x plus 17. And let's go ahead and graph it and see if the standard viewing window works. It doesn't look like it's working to me. I think I've chopped off a maximum and a minimum. Now our maximum looks like it's between -1 and +1. So to get caught up here, so again we entered into the calculator and we look at the standard viewing window. Again, this highest value looks like it's between x equals -1 and x equals +1. So, and the minimum looks like, oh gosh, somewhere between what? 2 and, let's see, 2, 3, 4, 5, 6, 7, 8. Somewhere between 2 and 8 maybe. So the relative max looks like it's between -1 and +1. So in my table of values, okay, and I said this time I'm using between 3 and 8. Okay, I already said 2 and 8. Well, I guess 3 is also good. So let's see what happens between -1 and 1 for x and between 3 and 8 for x. So we're going to look at the table of values. It's on the next slide. Okay, between -1 and 1. Okay, let me go ahead and use this calculator because that way I can slide around. So second table. Whoops, I got to change my table settings, don't I? Table set. I don't care where I start at, but let's use 1. So between -1 and 1, looks like my highest value was 17. So my y max needs to be bigger than 17, perhaps. Now, somewhere between 6 and 8, we said, or 2 and 8. Okay, it goes down to, wow, -79. So, looks like the relative minimum is somewhere below -79. I happen to choose -100. And then for the max, again, something bigger than 17. I picked 20. Okay, again, nice round numbers. I'm inclined to leave the x, max, and min the way they are. But now this minimum of -100 for y and a maximum of 20 for y, I should probably change my y scale. I mean, if you're saying that you don't want to, that's fine. I mean, this will let you see stuff, and of course you can always use trace to find the x values if you wanted to. But I'm going to keep the x settings the way they are. I'm using y scale to be 10, multiples of 10. Okay? It's somewhat arbitrary. But with those settings, okay, so all the x stuff stayed the same. Y min was -100, y max was 20, y scale was 10. Now remember, this is going to move the coordinate axes. There's the graph. Okay, there's the graph. I'm not really bothered by having the origin be down here in the left-hand corner, but it does kind of bother me to have it right there. So remember, how could you fix this? Change your y max to +100, in which case you probably definitely want to change your scale. Anyway, that's enough to see the max, the min, x-intercepts, and y-intercepts. That's the end of section 2.2.